Hello, everybody. My name is Teddy Jones. I am a senior in my final year with Valencia College's Computing Technology and Software Development Bachelor's Program. This is for my Advanced Software Development Seminar class, and this is my project Spin to Win API. Now, what Spin to Win is, or what it aims to do, is it aims to be a competitive meta tracker for the Beyblade X competitive scene. Specifically, what it high end does is it scrapes internet data from a commonly used tournament site for a lot of Beyblade X tournaments, and it picks the most parts from it to see which one is the most winningest, which is the one that people may see a lot when they go to tournaments. That way, if they wanted to prep against it, or if they just wanted to themselves use one of the best bays around, they would have that information and knowledge to make that decision. So, like I said, this project, my name is Teddy Jones, and this world that we're building, let's just call it the arena, okay? This is a competitive world that's dominated by alternative sports like esports, and in situations like that, equipment choices matter. This is the concept known as meta, or the most effective tactic available. But for physical sports like Beyblade X that use physical things, tracking that data, whereas like going on to an esports team's website, or going to like League of Legends for their LOL esports page to keep track with the League of Legends esports scene as an example. That's very much easy to do, but tracking it for a physical sport like Beyblade X is a lot harder, and this devolves into two reasons of why it's an issue. There are broken down further from there. Specifically, the problems boil down to two things, and they come from complexity and disconnect. Specifically, the complexity of integrating a system that can track not one, not two, but three, possibly four now different Beyblade systems within one system. Then you have the added complexity of trying to track in, well, how do these tournaments perform? Is this data related to one particular Beyblade stadium? Is this factoring in regardless of what stadium it was used in? Those complexity questions need to be resolved, and I do believe that is something that Spin to Win tackles. It takes that decentralized anecdotal data that we may get from Takara Tomy or Hasbro tournaments that are officially run by the companies that make the product, but we also have to take in the decentralized anecdotal data from the World Beyblade Organization, which is the fan-run community event, whose actually boots on the ground is what's keeping the competitive Beyblade X scene afloat. But also, there's no real place that you can go to track that information. I mean, you can go to the website that I used here, and I'll get further into that. But that's only just to track tournament points. It doesn't really track what Beyblades they were doing, but I have a workaround for that, specifically for my program and what it solves. Okay, so these are our problems. We have decentralized data. We have complex, parts, because not just do we have possibly four different Beyblade systems we have to do. Some Beyblade systems have more parts than other parts. It's a lot mess. The best way to explain it is BX and UX have three parts each. They have an attack layer, they have a ratchet, and then they have a bit, which is the little part that they spin on at the bottom. Okay? For CX line, which is still part of Beyblade X, it allows for more customization. So they separated the attack blade into three different parts. You have your lock chip, you have your attack blade, and then you would have an assist blade underneath it. And that complexity in those differences between them I have solved to put it into a unified platform in which you can ingest this information for all current available at the time when I made this Beyblade platforms. I say 4 now because in the process of going through all of this and creating all of this, they just released the Infinity series within Beyblade X. So BX, UX, and CX all have Infinity versions. I had not added any of those guys to, any of that tournament data that we'll be looking at. This is just the standard BX, UX, CX lines that Takara Tomy and Hasbro have released. Now, the solutions to all those problems that I had just mentioned is we want to eliminate guesswork. So this API, essentially what it does is it eliminates that guesswork by aggregating real match data from Challenge, which is the site that I'll be using when I go over our demo. I'll show you a little bit more about it. Essentially, this is the tournament standard that the World Beyblade Organization has been using for all of their tournament brackets for as long as I can remember them being a scene. They've used this program. So instead of rumors, my application would provide that empirical evidence, and it creates a centralized database of verified wins. None of these tournaments in here that you'll be seeing are test tournaments. These are actual competitive data that I've had to manually scrape and add into the challenge platform by watching hours on hours of competitive Beyblade footage. I would say once I get down to my challenges, I'll talk about just the time sink of the project in creating it and everything. But a little bit more on the solution. Like I said, by leveraging this API, my Java, scrapes the internet and parses and it normalizes this data into, a complex string. For example, here I use Wizard Rod 960 ball. Now, keep in mind that is the preferred nomenclature and order that Takara Tomy and Hasbro have specified in reading the names of Beyblades. So I have personally gone in and for each tournament that I've manually entered, I have gone in and added the user and the Beyblades that they used. That way our system can read and understand that and pull it through, okay? This allows for real-time agility, and because my database separates all the components, it doesn't just allow you to see the Beyblade that won, it allows you to and see the full combo of everything. Because some people will be like, oh, well, there's many versions of, Wizard Rod, for example. Wizard Rod's a pretty competitive Beyblade. I would argue it's the meta-defining Beyblade right now in Beyblade X. And there are 2 meta ways that you can run it. 3 if you're really pushing it. But the first one, as mentioned here, is 960 ball. And what that makes Wizard Rod do is becomes a stamina powerhouse. It is notoriously known for outspinning everybody. And there's even people that have grown to hate this Bey because of how good it is, okay? It's I hate to use the reference because I don't necessarily like Tom Brady, but it is like the Tom Brady of Beyblade parts, okay? But there are different combinations that you can use with it. Let's say you want a more defensive build. Well, then the perfect counter for that, you would have Wizard Rod, but instead you would have it on 160 and the bit would be Hexa. And that allows for a more defensive thing. So to allow myself or allow users, because I think of myself as well as a user because I am a competitive Beyblader. I collect the parts. I don't want to detract from my presentation too much to take time to show you all of my Beyblades that I do have. Just trust, I have a lot of them. Been a fan since 2001. That being said, it's always important to know the full combinations because Beyblade has always been about customizing for the best, most efficient tactic available. Remember, the meta, right? So allowing the users to fully see what's in the meta is a big solution that, Spin to Win, aims to give them, okay? And how we do this here is we're going to talk a little bit about the system architecture. We'll break it down into our three topics here. We've got our back end, For our backend, we use Spring Boot, and we use Spring Data JPA for the database interactions. Hibernate is used for query execution. We implemented for our data flow a challenge service to fetch, parse, and convert that raw string data into a normalized SQL scheme, and I can show you kind of what that looks like on the bottom end here. You can see all of my little source files here. Let's go ahead into my main Java. And yeah, you can see my properties here. Let me just get but yeah, as you can see here, it pulls in data from 4 different tournaments, and then it will display that user data, or that extracted data, as you can see here. Bear with me here. It closed out of it here. Let me. Once I get to the demo, I could fully show you through how many specific tournaments that it actually pulled in to show you that it's actually scraping data here. As you can see here, we're going to start the program. But the reason why we are showing you this from this end here, because it actually shows you, move my camera down here, it already contains database matches. I've put this in there to make sure that there are no duplicate matches being entered and not ending up with like a million that are just the same tournaments, because that can skew research. But as you can see here, by running this application, it does in fact check if there has been more tournaments added to the list here, and then it tries to pull that information to our project here. So I'll go ahead and back out of that. That's our data flow. That's our challenge service that parses that information. And then we have a dashboard. So this dashboard is done with JavaScript and chart.js. It's very simple. I'll go ahead and pull it up here for you now to give you an example of what that looks like. This is our dashboard here, and I'll get into what all this means after that. I just wanted to show you. Some of the things to note here, I wanted to make sure that I followed all imaging and branding of the Beyblade to keep it as closely related as I can without legally stepping on toes. So all the colors and all the different data that you're seeing, to keep it uniform, it's all kept within this cyber aesthetic. So think very neon colors, or another way to explain this, think of the sports that really pop for esports, and they're very similar because Beyblade X was built around this Beyblade is for everyone kind of vibe, and the colors reflect well with esports because esports truly is for anyone. Anybody can pick up and be really good at a game and make it in the competitive scene of an esport. Doesn't necessarily matter your age. So I wanted to keep all that in here. And we can see some data here that was generated from from our tournaments here. As you can see here, the 89 matches tracked. So we are looking at information that was just pulled into this little dashboard. So how did we all do it? All the tools I used, the ecosystem in its entirety, I used Java 23. Specifically, I used SQL through Microsoft Server SQL. We used HTML5 to be able to generate the dashboard, CSS3 as well, as a combination there, as well as JavaScript. Our frameworks are based, as I said before, on Spring Boot. Our API that we're using is Challenge's own REST API, and the IDE we're using is IntelliJ IDEA. Now, some of the technical challenges, as I had mentioned before, I said I would get to this. One big problem that I ran across when I started this project is I started by putting BX and UX bays in. And I got results because those parts are uniformed one-to-one. As I mentioned before, they added more complexity. They added the CX system. They added a new stadium. Those things, when I tried to update our system, created null and undefined all over the dashboard, so I really could not see anything other than, undefined, 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 all the way through. All of this, all of it undefined, all this information not showing the correct parts in undefined. It was a mess, and it particularly stemmed from the fact that the system was trying to read UX-BX bays as also CX bays and did not understand the differences between them and understand that only CX bays will have the extra 3 parts for their attack layer, not BX UX bays. So we made sure that the system was compatible, or I'm talking about me because I'm the one who made it, but specifically I wanted to make sure it worked with various Windows OSs. Specifically, we wanted to make sure that, when I was pulling everything in, looking at Git, and looking at my messages and uploading everything, I wanted to make sure everything that was as smooth as possible because I'm only familiar with Windows OS environments. So this was my best way for me to ensure that all documentation and all coding that I need to do would be uniform through the platforms. It's also influenced my decision to choose the Microsoft SQL Server because I'm also certified in Microsoft Access, and Microsoft Access kind of evolved into that. So yeah. Some more technical challenges that we had was, we wanted to make sure that we had non-scrolling elements on the page. We wanted to make sure that, when applications are used on the program, specifically when a tournament updates, like let's go look at our dashboard here, right? And as you can see, we have Wizard Rod as the most dominant blade, and it makes sense. Like I said, it's the Tom Brady. You can actually see the data here that, it is the most used attack layer. You can see 360 here is the most used popular ratchet, And as you can see here, the most popular one is Low Orb. So the popular combination, the most popular according to our dashboard here, would be Wizard Rod on 360 Low Orb, which is a competitive winning combo. It's outside of the 3 that are most well known, but it is just enough of that edge and difference from 960 Ball that it could, easily, based on this data, squeak out those wins. So, like I said, some of the constraints, I kind of scrolled past it. I do apologize. I'm talking here in a circle. But based on this information here, as you can see here, this is what I was trying to get to. Based on the dominant blade, that information could change based off of more tournaments coming in, correct? That being said, to make sure that this image here for each Beyblade that would change based on the new information and new tournaments put in, it should update to any of the bays that are currently listed in the system. And I do want to take as part of the technical challenges portion of what we're talking about here, very much so a big constraint that we had was making sure that those images stayed the right size in that, it didn't, blow up images or shrink images unnecessarily. But also we had to encounter some paywall stuff, you know what I'm saying? Which was annoying. You would think for students and working on projects like this, there would be more opportunities out there for companies to want to work with students. Getting access to like Challenge's API and stuff like that, working with this version of my ID, they're not cheap. These are all licensed keys that are very expensive. So that's some of my technical challenges and non-technical challenges that I had to deal with. But let's talk about some successes. As you can see, we have automated data integrity. As you can see here, it self-regulates when searching as to not pull in any duplicates. That is very important because that can skew, like I said, how many ever wins a particular bay may have. That could drive up their listing or their ranking on the list. We don't want that, so we made sure that it was, it maintained that integrity throughout it, and it wouldn't pull in any duplicates, you know. We normalized different product lines. Like I said, we made our system so it's able to understand different versions of UX bays. We can go ahead and look at our specific coding for that and our entities. And as you can see here, this is some of our code. This is to let our system know what a bit is, what a blade is, what a match win looks like, what our ratchets are. But also you can see here CX assist blade, CS lock chip, CS main blade. We'll go ahead and look into these ones that are each of our public classes here. And this is, like I said, this is to specify that, these are significant and different from the normal UX line. Takara Tomy separates it for that reason. I prefer to keep it separated for that reason, just simple enough. We did this by utilizing coalesce and left join within Hibernate to prevent all those null, constraints that we were having before, breaking of the dashboard. And then we implemented a JavaScript-based lookup system that swaps high-resolution assets, aka the pictures here. Pull up my image here. The pictures down here, we wanted to make sure, like I said, that it updates based off of whatever information that comes in. So let's say we put in information that, boosts Cobalt Dragoon up here to like 12 wins or whatever. The theory or the reasoning behind it, is because a new tournament came out and a new part just came out that really put, Cobalt Dragoon finally over Wizard Rod. This information in this display, once it is run successfully, would update to show that the dominant blade is Cobalt Dragoon, and it would display an actual correct image of Cobalt Dragoon. Rather than parse the internet and make our software itself understand what a CX Beyblade or a UX Beyblade or Beyblade X in general Bay looks like, I just found it a lot easier to just take a repository of every image that I could find for each Beyblade and dump it all into my database, in which we did that from there. I do apologize about that. Some things I would do over in this project. I would essentially build a database registry logic before the initial import of tournaments. That way I can streamline the early development of the data flow. I had to go back and, like I said, delete so many duplicates because it kept pulling in duplicate information. That was very frustrating, so I would try to streamline that process. Also, I mentioned here that I would go back and have it, implement some sort of API that could scrape images off of it. But I left this here because I did want to mention, and because I was kind of back and forth on whether or not I should keep this on here. So I did want to put it on here to address it. I do think that is a possibility of a feature that I could have implemented, is maybe have it be scraping. But after some thinking, I just don't think that it's really feasible or realistic right now with my coding ability to be able to create something that could parse the internet accurately and pull out that information. So my best solution for this is to entirely just hard code the locations of the images for the purposes of displaying everything and showing you everything that works correctly, but also introducing that data into my GitHub collection where you can find all this information. As I show you here, this is the link to the repository. I'm going to go ahead and open it up here. As you can see, this is the files for all of my program. Everything is here, including a robust README, including what tech stack, what the logic behind it. But also, this is the data collection and how everything looks. As you can see here, Cobalt Dragoon, based off of this as a combination, this combination was the most winningest combination. However, as you can see, Wizard Rod was up there. Wizard Rod being the most dominant blade, as you can see on our dashboard here, based off of how many more wins. Yes, Cobalt Dragoon went further in the tournament. However, Wizard Rod had the better win record. So I just want to keep that mention out there. This is kind of the demo portion of it now. I just talk a little bit about what the data and what that all means, how to interpret it, etc. Okay, so as we mentioned before, generally Beyblades fall into, the simplicity's sake, I'm going to say 3 parts. The attack layer, the ratchet, and the bit, as I had mentioned before. For UX, the weight distribution for the metal is more outward. For BX, it's more inward, and for CX, you could take apart the bays, customize them more. That's the general way performance is affected. CX bays tend to be taller and lighter. UX bays tend to have an outer weight distribution, which helps them spin for longer generally. In Wizard Rod's case, it's basically almost a perfect circle. For Cobalt Dragoon, it's a diamond pattern, but it's still very good for a technique called spin stealing or spin equalization. But as you can see here, these are different actual Beyblades parts that were used in recent tournaments. Let me go pull up my Challenger. I had mentioned this here before. And these are the 4 tournaments that it was all based on. As you can see here, I'm going to pull up each one. You can see here, based on what I put in, what were the different Beyblades. This particular tournament heavily overemphasized on CX Beyblades. As you can see here, Pegasus Blast Wheel Level, that is a CX Beyblade. Because it has, any standard Beyblade falls into the name category, as I mentioned earlier. The attack blade, the ratchet, and then the bit in nomenclature. So Shark Scale, for example, here is our attack layer or attack, portion. 160 is our ratchet, and low orb is the bit. For CX, you can always tell that there's difference because it's, as you can see, 4 names instead of 3. Pegasus is the name of the lock chip or the little motif on the Beyblade. Blast is the assist blade, the attack layer of it, the top portion that actually makes contact with each other, that's metal. Wheel is the assist blade, level is the bit. And then obviously it should have a ratchet in here. For example, Hover, Wyvern 170, High Needle. But these are our tournaments that we based our data on. These were actually pulled from real, tournaments within the Beyblade X scene. These can be viewed on YouTube, for example. The Beyblade X World Championship 2025. This here was a tournament done by Takara Tomy. Another example, the S1 Nagano Cup 2025. This is a Takara Tomy run one. However, the November 2025 meta-analysis, the June meta-analysis, those are done by the World Beyblade organizations based off of tournaments of their own. I could show you some of what that looks like and how it plays out in the tournament. You can see the standings and you can see the logs here. Obviously, this is me reporting in who won what and whatnot. To manually put this in, as I mentioned, as one of my project constraints is it was a time sink. It manually took me many nights to get this data implemented into the system. That's why I consider it a project success, because of the fact that I was able to watch all of that. And mind you, when these tournaments come out, a lot of the times they're based on Japanese time. So it's 4 in the morning, 3 in the morning sometimes that I'm up, eyes wide really, for lack of better words, lack of sleep, to get this information and, create this full program for you. That being said, we're going to go ahead and fully walk through the project demo so you can see how everything works from start to finish. I'm going to go ahead and close this out, stop this programming. It's running in the background. We'll go ahead and run it again. But I want to make sure we have all instances of this closed. As you can see here, I'm going to go ahead and close this out now. So there's nothing running on my system here in any way, shape, or form in terms of the program. As you can see, IDE or IntelliJ is not running it, so we're going to go ahead and run it here. As you can see, again, it has started. We can see that it does have the 89 matches, which is fantastic. So it's skipping the auto import of those to prevent duplication. Now we're just going to go to our web browser here. And we're just going to type in local user, or local host, excuse me. And as you can see, it pulls up our dashboard successfully. So that is my spin to win API from front end to back end to everything in between. Thank you guys so much for watching. I hope to see you guys later.